Hello everyone, it's indeed inspiring to see you back again. And in this series of quantum AI, we are going to understand today about classical states and probability vectors. You might be wondering that why we are talking so much about classical information. And your question is right. I'll answer this. We are discussing about it specifically because we want to create a base. We want to create a reference point. So classical information, these concepts will become a base to understand more on quantum states and quantum vectors. Let us try to understand more about it. So here, if I talk about classical states, so you can consider a system, and this particular system, it stores information. Another thing is that it is finite. So it has got finite number of classical states. So we have a system which is storing information and it has got finite number of classical states. Let me give you some examples also. Now, to come up with an example, let me add up a new slide. Okay, yes. So, example of a bit. So taking example of a bit, what classical states do we have? So the number of classical states are 2. So we have 0 and 1. So two classical states we have. Very similar way, if we talk about another example of, let's say, six-sided die. So in case of six-sided die, what are the classical states? Can you answer? Write in the comment box. So here we have 6 starting from 1, 2, 3, 4, 5 and 6. So total 6, that is finite states we have. Or if we take example of let's say a DNA structure. So we have a strand of DNA. So in case of strand of DNA, the classical states which we will get, they are A, C, G and T. Similar way, we can take one more example. So I'm giving you so many examples so that it is very clear that what are the real-time systems and what kind of classical states they can have. So if I talk about, let's say, an electric fan. So for an electric fan, the classical states would be, yeah, so classical states we will have high, then low, medium, and then off. So these are the possible classical states we can have with electric fan. Now we need to represent these systems. Somehow we need to represent these systems. And for representing them, let's say how to represent these systems. So for representation, what we can do is, let's say x is a bit. So if x is a bit, then we can have the representation like in curly brackets 0 comma 1. This is how in a standard manner we represent, and this is a set of binary numbers. Okay, now we can have some special symbol. I'll have to take it from some internet. So this summation symbol I have taken over here. Let me just make it white and little larger. It looks a little smaller, right? Okay. So this is how I can represent. This is one way of representing if x is a bit, and let me make it a single pointer here. Okay. So this is how we can represent. Now very similar way, let's have if x is a six-sided, so if x is a six-sided die, in that case, what is going to happen? In that case, we'll have summation is equal to, and inside the brackets, we will have 1, comma 2, comma 3, comma 4, comma 5, comma 6. This is an example. Okay. Then again, let's move ahead. And here, if we have x is an electric fan, so in this particular case, we will have it similar way. So here we will have high, medium, low, and off. So these are the mechanisms, the way how we can represent. Now, if basically, let me take some example. So this is how we can represent. Okay. Now, how basically we can represent in terms of probabilities. So So if I want to represent in probability, I can write P or probably PR of X. Let's say X is equal to 1 in case of, let me take example of SIX 6 SIDD sided die. So the probability would be 1 by 6, because chances of getting X as 1 are only 1, and rest of the chances, if you see, they are of other numbers 2, 3, 4, 5, 6. This is the probability. Okay, if I basically try to understand for let's say a bit, so it is going to be probability x is equal to 0. Okay, so it is going to be 1 by 2, 1 by 2, and probability that x is going to be 1 is again 1 by 2. So this is how we'll represent the probabilities. Now, another more succinct way to represent probabilistic state is, so what is the succinct way? We can represent it with, probably I will not be able to represent like this. So let me just remove this. So I'll take some text boxes, and with the help of text boxes, I'll do that. So it will be like, for 0 it was 1 by 2. So 1 by 2, this is for 0. And in fact for 1 also it was 1 by 2. So this way. And then we'll have brackets. So let's have a bracket over here and some space in between. And let me have it like this. So this is how we can represent. Okay, so this is how we can represent. So this is more better way to represent the probabilistic state. Now, if you have any systems, whatever systems you have, you can find out the probabilities. Here it is a bit confusing in the sense, like, because both the probabilities are 1 by 2, 1 by 2. So what I will do is, I will have, let's say 0 is having probability of 1 by 3, let's say, okay, and 1 is having probability of um, so it is 1 by 3, and this is, let's say 1 by 4, and here let's say we have 3 by 4. So these are the two probabilities we have, 1 by 4 and 3 by 4. So what I will do is, this 1 by 4 will come over here now. Okay, let me remove this for some time. So 1 by 4 will be here, and this 3 by 4 will be here. Okay, and then yes, let's bring it back over here. So this is how the probabilities will be there. So normally what we do is, the way we represent the binary system is like we start with 0 and then we have 1. So the first, you can see, the first one represents the probability for 0, second represents probability for 1. So this is a vector and we are representing in a columnar way. So all entries of this particular vector, if you see, they are non-negative and real numbers, and if you do the summation, it is going to come as 1. So in general, we can represent the probabilistic state of a system having any classical states, infinite number, in this particular manner, and we will have some order to be followed. If it is a new system, you can define your order, and as I told you, here we have 0 comma 1 as a standard. 0 is represented first and 1 is represented next to it, so you can have it this way also. All right. So with these two important properties, that we will have all the entries with non-negative real numbers, and the summation of a probabilistic state would be 1. We will end this particular session, and in the next one, let us try to understand more about quantum states. Thank you very much. Stay with us. Keep watching.